Hi guys, in this video we're going to look at how different scientists have contributed to today's idea on the structure of the atom. We have already looked at John Dalton's atomic theory and the ideas or postulates under his theory. We'll now look at various scientists and see what they have contributed towards what we consider to be the structure of the atom today. We'll start with J.J. Thomson, and Thomson was the scientist to discover the electron. Now, Thomson's experiments involved applying a high voltage to gases at low pressure, and through his experiments, he was able to discover these tiny negatively charged particles called electrons. And from Thomson's experiments, he was able to split the atom, and this therefore was one of the pieces of evidence that was used to adjust the idea under John Dalton's atomic theory that an atom can neither be divided nor split. So Thomson proposed a new atomic model, and in his model he said that there are negatively charged electrons in an atom, and he considered these negatively charged electrons to be embedded in a cloud of negative charge. So J.J. Thomson's, I should say, idea of the atom became that of what is called a plum pudding model, right, where the electrons are said to be like plums embedded in a sphere of positive charge. After Thomson, we look at Rutherford, where Ernest Rutherford put forward the idea that Thomson's atomic model was not possible. Through his experiments, he determined that there was a concentration of positive charge at the center of an atom. Right, so through his experiments, he proposed that yes, there were electrons in an atom, but that these electrons orbited around the center of the atom, which we now call the nucleus, and that the center of the atom, where we have this concentration of positive charge, that the center of the atom contained positively charged particles called protons. So Rutherford was the scientist to come up with the idea of the nucleus, right, being a center of positive charge. And he also proposed the idea of protons, and that these protons are found in the nucleus, and that the electrons would move around the nucleus, right? So hence the term planetary model of electrons. After Rutherford, the next important development came from Niels Bohr, where he revised that idea or that atomic model, where through his experiments he showed that when atoms were heated, that light would be given out, or light energy, and that this light energy had specific amounts. So through his experiments, which we will look at later on in more detail, Bohr was able to propose that yes, there was a nucleus at the center of the atom, but that electrons would orbit the nucleus at fixed distances, or what we now call today fixed energy levels. Right, so Bohr proposed that electrons orbited the nucleus in fixed energy levels. right? We call this idea or Bohr's um, atomic model or his experiments we have later now identified as quantum theory, right? So Niels Bohr proposed that electrons orbited the nucleus in fixed energy levels. We call that the quantum theory. After Niels Bohr, other experiments were performed, right? There was speculation about another subatomic particle, and through Chadwick's experiments, he was able to discover the particle called the neutron. Of course, we know the neutron to exist in the nucleus, and the neutron is said to have no charge and, of course, the same mass as the proton. Last but not least, I will also mention Schrödinger, where Schrödinger, in his experiments, he was able to show that the electron was not just a particle, that an electron could also be considered to be a wave, where we can now consider an electron not just a specific point in space, but we can consider it to exist in a volume of space or quantity of space where we can state the position of an electron as a probability. Right, so I'm not being a little vague about it, but that's why we refer to an electron sometimes as an electron cloud. So we can say an electron is an electron cloud and that it can exist in any point within that space, and determining at which point it exists represents or is represented by a probability. We'll talk about this in more detail later on. You have to make sure and take down this very short note on the scientists and their discoveries that have now shaped our idea of the atomic model today.